Okay, the next success criterion is the 2.5.7 dragging movements classified as a AA requirement. Let's examine the normative section of the success criterion. All functionality that uses a dragging movement for operation can be achieved by a single pointer without dragging, unless dragging is essential or the functionality is determined by the user agent and not modified by the author. The aim of this success criterion is to ensure that functionality relying on dragging movements also provides an alternative single pointer mode of operation. This eliminates the necessity for precise dexterity usually required when dragging elements. Indeed, this criterion aims to offer an accessible alternative for individuals who find it challenging to perform precise dragging movements. When an interface integrates functionality that depends on dragging movements, users perform 4 distinct actions. The first one is tap or click to establish an initial point. Then press and hold that point. Next, reposition the pointer. And finally, release the pointer at the final point. However, not all users can effectively maintain pressure on the initial point while simultaneously repositioning the pointer. Hence, an alternative method must be accessible for users with mobility impairments who rely on a pointer device to utilize the functionality. Who gains advantages from the implementation of this success criterion? Individuals encountering difficulties in performing precise dragging motions. Users utilizing specialized or adapted input devices such as trackballs, head pointers, eye gaze systems, or speech-controlled mouse emulators. Common examples include maps and linear slider widgets, like those utilized, for example, for adjusting the audio volume level. In the upcoming video, we will review a user's attempt to interact with a dual thumb price range slider. Clicking on the track doesn't trigger any action, and the slider can only be interacted with by manually dragging and dropping the thumbs. Of course, this results in the failure of the 2.5.7 success criterion. In this second video, we'll examine another example of a dual thumb range slider, this time employed for filtering by time rather than price. We'll observe that while it's not optimal, it still does satisfy the success criterion. Clicking on the track prompts the nearest thumb to adjust its position accordingly, leading to a pass of the success criterion. However, interacting with the track at a middle position can be unpredictable, since it's unclear which thumb is closest, necessitating users to move the thumb incrementally to achieve the desired effect. In the next example, we'll explore another viable solution. Here again, we have another video showcasing a dual thumb price range slider. In addition to integrating one-click functionality on the track, the author has also incorporated 2 number input fields, enabling users to directly input the desired minimum and maximum values. Of course, this guarantees a predictable behavior.